All right, section 2.2, linearity and symmetry. All right, so the first part of this, I think it's fairly straightforward in the sense that we're going to be talking about linear functions compared to nonlinear functions. And by the way, we're going to spend a ton of time talking about functions now. Section 1, we talked about relations. Some of them were functions, some weren't. Right now, though, and in the near future, we're going to be talking about functions, okay? That, again, means the graph will pass the vertical line test. Let's talk about linear functions. They are functions that, when you graph them, make lines. Hence, they're linear, all right? Nonlinear functions are functions that, when you graph them, don't make lines, all right? So the lines can't be written in the form of f of x equals mx plus b or y equals mx plus b. Those mean basically the same thing, okay? So let's look at these functions here, and let's see which ones are linear and which ones are not. So first, this one, the upper left, is definitely a linear function. Nothing sneaky about that one. This one is also a linear function. This next one is weird, all right? Why is it weird? Well, it's got two x's there, and it's got an x times y. And what's going to happen is, when you try to get y by itself, you subtract x over. Also, I'll show you what I mean here. You'll end up with this. Y equals negative 5/8 divided by x. I'm going to erase this too, so it's not in our way later, but minus x over x. All right, you might have to trust me on that, but what's going to happen here is we're going to have an x in the denominator of a fraction. That will make a graph that is not a line, okay? So this one is nonlinear, like I said, so let's erase that one. And you guys, you can always check Desmos, okay? So if you are in doubt, just check Desmos. There's two things really that you're looking for here if you're trying to figure out something that's not linear. A power on the x, an exponent on the x that is not 1. So if it's negative, positive, or some sort of fraction. Square roots of variables, so of y or of x. And also a variable in the denominator, okay? So we've got other exponents, or exponents other than 1 on x, roots on x or y, and x is in the denominator of a fraction, okay? This next one then is going to be out because we have a power of 2 on the y. That one's not going to be linear. The next one, if you were to go solve that for y, you would find that actually it does work out to be a linear function. And this last one, 1 over x, not going to work. Again, you can graph it and see, you can graph it and see, but that is not going to be a linear function. All right, let's move on to this application problem here. The graph and the table model two different predictions for snakehead fish population. We want to look at both of them and see if either one of them is a linear function. The first one here, pretty clearly not a linear function, just because you can see that it's starting to curve. And so this one is no, this is not a linear function. You could go look at those points and use the method we're going to use on model B, apply that to model A. You'll see what I mean in a second, and you'll find that it wasn't linear. But let me show you what I mean here. So for model B, we just have a table of values. So we can't really look at it unless we graph the values. But we don't need to. Let me show you why. We've got time on the left. Every row goes up by 1 year. Okay, and on the right, we can look at the difference in the population from year to year. So from the first year to the second year, the difference in population is 25. From the second year to the third year, the difference in the population is 25. Same thing here, from second to third, and from third to fourth. Whoops, I think I wrote 24. Try again, 25, and then 25 here. All right, so what we can say then is that this has a constant rate of change. Every year, the population goes up by 25. So you might even write that down. It's a really important phrase. It has a constant rate of change. Okay, that means constant slope. Rate of change is the same as slope. Okay, so it has a constant slope, constant rate of change. Therefore, it is a linear function. If you were to plot all of these points, you would get a straight line if you were to connect those dots. Okay? All right, so that's the linearity piece of this lesson. It's kind of broken into two parts. We just did linearity. Let's talk about symmetry now. All right, so let's talk about line symmetry and point symmetry. You guys are probably familiar with some of this, especially because you were just in geometry not that long ago. Talking about line symmetry. Line symmetry just means that each half of the graph maps onto the other half of the graph. The dividing line, the line that cuts it in half, is called the line of symmetry. Okay, so in this one, you can see there's a line of symmetry right here. Let's see. Yep. Right about there. Right about at x equals 4. Okay, so this has line symmetry, and this line here is x equals 4. Okay. The other type of symmetry that's not quite as, I don't think, quite as obvious or quite as easy to see is point symmetry. And point symmetry is if the graph can be rotated 180 degrees, so a semicircle around, about a point so that the rotation maps onto itself. So that is, if I look here at 0, 0, you can see that seems to be sort of an important point in this graph. If I was to take this graph and rotate it 180 degrees, where would it go? Well, 180 degrees, come around like this. So that point would end up here. So then you ask yourself, well, where would this point go? Well, you start to see that like that point would go where the other point was. Okay, so this entire graph, if you rotate it 180 degrees, lands on itself. That's point symmetry. Okay, so let's go on and do a couple examples here. So what type of symmetry? What type of symmetry does the graph below have, if any? If it's point symmetry, about what point? If it's line, we're going to find the line too. All right, so does it have line symmetry? Yeah, it does. It has line symmetry right here. Again, for most students, it's not too hard to see in some of these. But yeah, that if you can draw a line right there through x equals 2, I think it is. You got to be careful of the scale. But at x equals 2, you have line symmetry. Line symmetry. All right. Going on to number 3, too. And how about we get rid of that? All right. So number 3, what type of symmetry does the graph below have, if any? If it's point symmetry, about which point? Yes, this one does have point symmetry. Again, you pick the point here, and the point that it's going to be rotated around. Check your scale. Looks like it's going to be -5. So -5, 0 would be the point. But again, you pick a point here, anywhere on the graph, and when it rotates around 180 degrees, you check where the other point went. You see that it's going to map onto itself. Then you have point symmetry. Again, that's that 180 degree rotation, and it's about the point -5, 0. And that's really everything for section 2.